All right, so next up for our last video, we're going to be talking about angles on the coordinate plane and converting, finally, between degrees and radians, so the two different systems that we have to measure angle. So first off, what is standard position? This is when the vertex is at the origin. And our initial side is on the x-axis. So if we're taking a look at this on a coordinate plane, we'd see a few different examples here, but I'll start off with this one. Here's the vertex of the angle at the origin, and here is the initial side. Next, we have the terminal side of an angle. So that would be if we're drawing an angle out like this. That would be our terminal side. And going from here to here, that is our positive angle measure. Now, this is not the only way that we can draw these. For a similar angle, we could also see it going the opposite direction. So again, initial, this time maybe our terminal is down here, and then we would have a negative angle measure. And actually in both of these cases, there is both positive and negative measure. If we had positive measure, we would start here and go all the way around. And in the other case, this angle, we would start here and loop around to see our negative measure. So actually for both of these, we're going to see that they are two different ways of measuring the same thing. So for example, if our positive measure here was, let's say 60 degrees, we know that positive plus negative adds up to 360, that's a full circle. So this would have to be negative 300 for that angle measure. For negative measure down here, maybe this negative measure is negative 45. Well, in that case, our positive measure would have to be 315. Again, put those together to get 360. So two different ways of saying the same thing, but the important thing to note is that we always start off on the x-axis. Positive means we go counterclockwise, and negative means we go like a clock, we go clockwise. So two different ways to say the same thing, but again, both of these are going to come up quite a bit. So they're going to ask you, based off of these things, based off these measures, where does an angle lie? So for example, if they ask us for negative 300 is in which quadrant? So we'd start off here with our angle measure, and then we'd have to see how far over does it go. So 360 is our full loop, and then each of the axes goes an additional 90 degrees across. So positive measure is 300, and it looks like that's going to bring us somewhere over here. So here is our terminal side. We're going to see that this angle is going to be in quadrant 4. You can think about the mood meter for this one. So quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. So that's how we measure it, and we just kind of want to see where are they falling, and that's what most of those questions are going to ask. It's kind of like either draw a sketch or just see once you've drawn that sketch, where does it fall? And you can use the axes as reference points. So if it's bigger than 270 but less than 360, we know that that's going to lie in quadrant 4. If it's somewhere between 0 and 90, that's a quadrant 1 angle. Kind of the reverse goes true for negative angles. We just kind of have to measure them going the other way around to see where they go. All right, the last thing that we're going to cover is radians. It's a pretty standard unit of measure. commonly used in calculus and physics. So we're going to have an introduction to it here in Algebra 2, and then honestly, in most of the math classes beyond this, you're just going to see radians pretty commonly used, probably more so, honestly, than degrees. So understanding what radian measure is, we basically just have some conversion factors for it. So if we take a look here, set up our initial angle, and we can see the factors. So first one, to go from degrees to radians, we multiply by pi over 180. And to go from radians to degrees, we multiply by the inverse, 180 over pi. So for this, I think the easiest thing to do actually is we can set up our axes. So we start off at 0. 0 multiplied by pi over 180 is still just nothing. It's still 0. But what if we try here with 90? So we'll go from 90 degrees to radians multiplied by pi over 180. We're going to see that we'll get 90 pi over 180, or in this case, just pi divided by 2. So 90 is the same thing as pi over 2. Same thing for 180. We could set that up using that kind of same conversion factor. 180 times pi over 180. Well, in this case, the 180s just cancel. We end up with pi. We can try it the other way around here. So we start off with 3 pi over 2 as our radian measure for this. And we can try to convert that to degrees. So 180 over pi in this case. Well, the 2 pi's simplify to 1. And then we can do it the other way. It might be a little bit easier. So we'll get 540 divided by 2. 540 divided by 2 is 270 degrees. And then finally we can go full circle. This would also be the entire circle, or 360 degrees. And if we were to do 360, convert that to radians, we would get 2 pi. So that's kind of how we go back and forth. So they're going to ask you to be able to convert both ways. You got to be able to understand which factor are we multiplying by. Are we going from degrees and ending in radians, or are we going from radians and ending in degrees? And then secondly, once you've done that, you want to be able to use your initial side and actually draw what that angle should look like. And again, these reference points on the axes are going to help you place which quadrant the angles belong in. All right, so let's go on to some practice questions, a little bit of conversion here, and also some practice.